Years and seasons. Years. The Earth takes, as we said before, 365 and a quarter days to complete or to orbit once around the sun or to make one revolution around the sun. 1 year, um, to make 1 year, I'm sorry. The leap year, it means a year that has 366 days. That happens every 4 years. We have seen already that different planets take different lengths of time to orbit the sun. That means their years are different lengths. Mercury, for example, has a year of just 88 days from the Earth. Neptune has a year of 164 Earth's years. So Neptune, because it's farther or the farthest planet from the Sun, it takes 164 years to complete one orbit around the Sun. And Mercury, because it's the closest planet to the Sun, its orbit is so small, so it takes just only 88 days to complete one orbit around the Sun. Let's talk about the leap year. The whiteboard. Earth to complete one orbit around the Sun takes 365 and a quarter days. In the leap year, we add the quarters of the 4 years together, each 4 years, to make, we consider this day in 29 of February in the leap year to be 366. The year 365, but we adding these quarters together to make one day in each 4 years, which is the 29th of February, to make 360. The year contains 366 days, okay, in the leap year. Of course, you know that from the previous years. Let's talk about the seasons. The rotation of the Earth around its axis causes the day and night. That happens every 1 day. The 4 seasons, which are the winter, spring, summer, and autumn or fall, happens every 1 year. This is because the Earth orbits the sun. Okay, why do we have different seasons? First, the Earth orbits the sun, and its axis is tilted or inclined axis. Let's go to the simulation to give more explanation for this part. This is the axis of the Earth. This axis is inclined, okay, not in upright position like this way, not an upright position in this way, no, but it's inclined, little bit inclined. That leads to that leads to The northern hemisphere of the Earth, or this part, inclined away from the sun, and the southern hemisphere of the Earth inclined toward the sun. So this part will reach to more sunlight perpendicular. So this part have summer, and this part have winter. Let's move. When the Earth moves from here, from this point to this point, in this time, or in this position, the northern hemisphere is inclined toward the sun, so the sun rays falls perpendicular, okay, and this part, the southern hemisphere, is inclined away from the sun. So by this way, this part has summer, and the southern hemisphere has winter. The sequence of the four seasons, winter, then spring, summer, autumn, and so on, okay, happens because the Earth orbits the sun. And when the Earth orbits the sun, its axis inclined. So sometimes the north part of the Earth inclined away from the sun, so they have winter, while the other half, or the south half, has summer because it's inclined toward the sun. After 6 years, which is the half of the after 6 months, or after the half of the year, when the Earth moves from here, from this position to this position, this half is inclined toward the sun, so they have summer, and this part is inclined away from the sun, so they have winter. Let's move. So, while the north hemisphere has winter, the southern hemisphere has summer. Okay, let's stop. Sorry, start again. In this position, exactly, okay, the two parts of the Earth, the sun rays, falls equals in the two sides. So this part has a spring in the spring season, and this part in the fall or the autumn season. Let's continue. The quarter of the year, the half of the year, and here the 3/4 of the year. Let's stop the video. Like this position, like this position. Here, the two parts of the Earth, they receive the same amount of light because the light fall perpendicular in the both side on the equator. So this part has fall or autumn, and this part has spring. So this phenomena happens because the Earth orbits the Sun, and also while it orbits the Sun, its axis is inclined. Sometimes that makes some parts or the north part inclined toward the sun, is inclined toward the sun, or is tilted toward the sun, so they have summer, and the other part away from the sun, so they have winter. And when the earth come here, the north part is tilted away from the sun, and the north part is inclined toward the sun, so they have summer and so on. This happens every 1 year. Let's go here. Why do we have different seasons? Because the Earth's axis is tilted. When the northern hemisphere is tilted toward the sun, it is a summer. Longer days, the daytime, okay, or the appearance of the sun in the sky, longer than, and the sun is higher in the sky or hotter. When the northern hemisphere is tilted away from the sun, it's winter. The daytime or the appearance, the duration of the sun in the sky is so short, with the sun lower in the sky or cooler. Okay, in this diagram here, as we said before, the inclined of the earth, I'm sorry, the axis of the earth is tilted or inclined, so that makes the north hemisphere in winter, while the south hemisphere or the south half in the summer. The earth goes to complete half orbit. Okay, north hemisphere now is tilted toward the sun, so they have summer, and while the southern hemisphere, it has winter. Okay, and here the spring and autumn, here the autumn, and here is spring. Okay, so to discuss it in more details, when for example, this is the northern hemisphere or the north part or the north half of the earth, tilted toward the sun. That makes the sun rays falls perpendicular on this half. Sunlight falls more directly or perpendicular on the northern hemisphere, making the solar energy more concentrated. Notice the smaller shadow. The shadow becomes smaller in the summer, and making the sun's path longer and higher through the sky. Okay, and the duration of the day is longer than the duration of the night. Okay, while the other side or the southern hemisphere, okay, the sun rays not falls perpendicular or not falls directly. Let's discuss when the northern hemisphere has winter. In the winter, the situation is reversed from the summer, with sunlight fall. The sunlight does not fall perpendicular on the northern hemisphere, but it's fall perpendicular in the southern hemisphere. Okay, so that makes the shadow in the winter longer. If you notice here, the shadow of this person longer here because it's winter, and longer here because in this part there is a winter. But here the shadow is shorter because it's a summer, and the sun rays fall perpendicular or fall directly, and here in the summer, in the south part, the sun rays fall directly, the shadow is shorter. Why the sun moves higher in the sky in summer than in the winter? Why is it hot in summer and cold in the winter? Because the Earth's axis is tilted. Okay, in the summer, if you notice the position of the sun in the noon, you will find that in the summer, the position of the sun is higher than the position of the sun in the winter. And the duration during the summer, the duration of the daytime in the summer is longer than the winter. For example, the daytime hours maybe reaches to 16 hours in the summer and shorter night in the summer. But in the winter, it's opposite. Longer night and shorter day time. Okay. During the summer, the sun's rays hits the earth at a step angle. The light does not spread out as much, thus increasing the amount of energy hitting any given spot. Also, the long daylight hours allow the Earth plenty of time to reach warm temperature. During the winter, the sun's rays hit the Earth at a shallow angle. Here, step angle, here, shallow angle. These rays are more spread out, which minimizes the amount of energy that hits any given spot. Also, the long night and short days prevent the earth from warming up, thus we have winter. Okay, this is the end of this unit. Thank you, dear students.